Okay, section 6.6 is inverse trig functions. It's an introduction to them, and then also derivatives and integrals involving inverse trig functions. So there's a lot of information in this section. This video is only going to cover the beginning part where we define the inverse trig functions. So you need to make sure to read the whole section in the book. We'll go over some of it in class, but there's just not enough time in the video and in class to cover every detail of everything, so you've got to also read the book. Okay, before we get to inverse trig functions, let's talk about inverse functions of things that maybe are a little simpler. So here's a graph of f of x equals x squared. That's a nice simple parabola. Now, this thing fails the horizontal line test, right? Which means it's not one-to-one, which means it doesn't have an inverse function. We know that. When we talked about inverse functions, if the graph fails the horizontal line test or if the function's not one-to-one, it doesn't have an inverse. But instead of giving up, we're going to change the function slightly. And the way we'll change it is by changing the domain. The original x squared function, the domain was all real numbers, but now we're going to sort of artificially limit ourselves to the domain 0 and bigger. Right? So we just sort of erased the left half of the graph, and now we've got x squared for x greater than or equal to 0, which is the right-hand half of the parabola, including the bottom point, the vertex, at x equals 0. Okay. This graph passes the horizontal line test. It's a one-to-one function on this domain, so it has an inverse, and its inverse is actually f inverse of x is the square root of x, right? If the original function squares, then the inverse ought to undo that, which is take a square root. So we achieved this. We achieved an inverse for the x squared function by restricting the domain of the function. That is, now we've found an inverse, but it's not technically an inverse to the full function. It's an inverse to sort of a piece of it. A restricted function, restricted the domain. We're going to have this same idea now applied to trig functions. In particular, if you look at the sine function, f of x equals sine x, this is its graph, more or less. It's this infinitely repeating periodic sine wave. And so, boy howdy does it fail the horizontal line test, right? Any horizontal line you draw just about will hit that thing infinitely many places because it just keeps going both directions, repeating that same wave over and over. So this definitely doesn't have an inverse. It fails the horizontal line test badly. But, just like with the x squared function, if I only look at a piece of it, I can restrict the domain and get something that passes the horizontal line test. Now there's lots of pieces I could pick, lots of domains I could choose to restrict to. The standard choice, and the one we'll use, is the domain where x is between negative pi over 2 and positive pi over 2. So that's including the origin and goes from the bottom of that hill to the left up to the top of the hill to the right. Okay, so this bold purple part is the piece that we're looking at. Just this purple part of the function, that passes the horizontal line test, so it has an inverse, right? So the sine function as a whole doesn't, but the sine function just between negative pi over 2 and positive pi over 2 does have an inverse. And we call that inverse the inverse sine function, which you can write sine with a little -1, or we call it arc sine. Maybe I'll tell you why in a little bit, I don't know, but there's historical reasons. I tend to write arc sine because sine inverse, sometimes I get confused and I think that -1 is an exponent instead of an inverse function, but you can do it either way. You can write either one. Arc sine is the inverse of this restricted sine function. Okay, so the restricted sine function has a domain restricted to negative pi over 2 up to pi over 2, including those two endpoints, right? That's what we restricted the domain to. And its range is the same as the range of the original one. The y values it covers go all the way from -1 up to +1, the bottom of the hill, the bottom of the valley to the top of the hill, right? So what are the domain and range of the inverse sine or arc sine function? Well, remember, if you have a function and you take its inverse, the domain and range switch. So now the domain of the restricted sine function becomes the range of the arc sine function, and the range of the restricted sine function becomes the domain of the arc sine function, right? So the arc sine or inverse sine function has domain from -1 to +1, and range or outputs from negative pi over 2 to pi over 2. Okay. So remember that inverse functions switch the role of input and output. So I could write sine of pi over 6 equals 1/2. That's true. And so that means if I switch the input and output, I've got a statement about the inverse sine, or arcsine function. Arcsine of 1/2 equals pi over 6. In general, if sine of a equals b, and remember this is the restricted sine function, so that a, that input, has to be in the right domain, that means the same thing as the arcsine of b equals a. Switch the input and output, and it's arcsine or inverse sine. So that tells us how to find arcsines of things, right? Arcsine of x outputs an angle, because sine inputs an angle, right? So arcsine of x is an angle. It will be in that interval between negative pi over 2 and pi over 2, and its sine is x, right? So arcsine of 1/2 is the angle in that interval whose sine is 1/2, and that happens to be pi over 6. What's arcsine of the square root of 2 divided by 2? Well, it's the angle in this interval, in between negative pi over 2 and pi over 2, whose sine is the square root of 2 over 2. Now, you have to kind of remember your special angles at this point. I am going to make you remember them. You need to know sines and cosines of 45 degrees, 30 degrees, 60 degrees, and you also need to know about 0, pi over 2, pi, 3 pi over 2, and so on. So the unit circle stuff that you may have had to memorize in pre-calculus or trig is back. Right, so which angle has sine root 2 over 2? Well, that's one of the things related to 45 degrees. Since the sine is positive and I'm only allowed to look between negative 90 degrees and positive 90 degrees, or negative pi over 2 and positive pi over 2, that means it must be actually 45 degrees. I think in degrees, but I write in radians, right? Because calculus works better with radians. Derivative of sine is cosine only if you're dealing with radians, and so on. So instead of 45 degrees, I will write pi over 4. Let's do another example. What is the arcsine of negative square root of 3 over 2? Well, it's the angle in this interval. This time I'm displaying it graphically. Negative pi over 2 to positive pi over 2 are these two right-hand quadrants of the unit circle. So it's the angle in that section of the unit circle whose sine is negative root 3 over 2. Well, sine of 60 degrees is root 3 over 2. If I want the sine to be negative, it needs to be down below the x-axis instead of above. So negative 60 degrees in radians, that is negative pi over 3. The arcsine of 0 is the angle between negative 90 and positive 90, or negative pi over 2 and positive pi over 2. The angle in there whose sine is 0. Well, sine of 0 is 0, so that's pretty easy. Arcsine of 1, it's the angle in that interval whose sine is 1. The only one is 90 degrees, so pi over 2, and so on. Okay, so this is how the arcsine function is defined. Now, arcsine and sine are inverses, and normally when you do an inverse function and then the regular version of the function, they undo each other and you get back to where you started, right? So normally if you did f inverse of f of x, you would get x. But inverse sine of 3 pi is not 3 pi. So these don't quite cancel out all the time. Why is that? Well, arcsine has to give you an angle between negative pi over 2 and pi over 2. So this thing works, arcsine of sine of x equals x, only works if x is in the right domain. If x is between negative pi over 2 and positive pi over 2, you can cancel arcsine and sine, everything's happy. But in our case, it's not. So to find arcsine of sine of 3 pi, we actually have to do it step by step. Sine of 3 pi is 0, so we're asking for arcsine of 0, and we just figured that out, it's 0. Okay, so this is just a word of warning that they cancel if your x is in the correct interval, but not otherwise. Okay, so we did this with sine. We can do this same procedure, restricting the domain, with other trig functions like cosine and tangent and so on. But the same domain won't always work because of the way the graphs look. For cosine, it does not work to pick the domain negative pi over 2 to positive pi over 2, we have to pick, because it still doesn't pass the horizontal line test if you pick that domain. For cosine, we have to restrict to the domain from 0 to pi, that interval. If you do that, you can define this arc cosine or inverse cosine function. And it has the same idea as arc sine. That is, arc cosine of x is the angle in this interval, 0 to pi, whose cosine is x. You can do it with tangent, and the domain you need is back to negative pi over 2 to positive pi over 2. This time, however, you can't include those endpoints because tangent of pi over 2 is undefined. So it's just the open interval. And once you do that restriction, you can make arctan or inverse tangent, and the arctan of x is the angle in this interval whose tangent is x, and so on. You can also do it with secant, cosecant, and cotangent. They don't come up hardly at all, so you can look those up in the book. In 6.6, the section box 10 will have that information. In my book, it's on page 457. If you have a different edition or something, it might not be on page 457, but it's in section 6.6, and I think it's box 10. Okay. The derivatives of the inverse trig functions are in box 11. That's also on the same page in my version of the book, but you should go looking for it. You need to know those derivatives. You don't necessarily need to have them memorized for class tomorrow, but you need to have them memorized by the test. You'll work with them a lot. I'm not going to talk about how we get them. Please read that in the book. But this is where I'm going to stop for now. So a video question, bring this to class tomorrow to turn in, is what is the arc cosine of negative a half? I want you to do that without using a calculator. I want you to show me your work. So it should start off, arc cosine of negative a half equals the angle in blah, blah, blah interval whose blah, 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 blah. Fill in the blanks and then figure it out. Okay, so work that out, bring it to class, and I will see you there.